In this video, we'll look at a few more basic concepts for trig graphs, but with some lovely twists and tips along the way. And so the first one is when they ask you for the max or min length, especially for sine or cos, what I like to do is just put a box around the angle, and that max would be 1. So if I think of, let's just pick on the sine graph. A normal sine graph's max is just 1, same for cos, and a normal sine's min is -1. And so if they ask me max of 3 sine 10 theta, just put a box in your mind around the 10 theta, and that means that the max of this will just be 1, and then it's just 1 times 3, and the answer is 3. All that's happening with the 10 theta is you've just got a graph of sine that's going up and down, up and down, up and down, up and down 10 times, but it still only goes up to 1 and down to -1. Ditto when they ask for the min of 5 cos 87 theta, that's just a graph of cos that's repeating 87 times, but it's still cos 87 theta, the smallest that will ever be is -1, and so it's just -1 times 5 is -5. I'll put it into a exact question as we get to the next thing. Something that will blow your mind is that if they said, what is the maximum of sine 8x cos 8x, that means nothing to us really. And so you can magically times this by 2, because then this aspect of it would be a double angle. This only makes sense typically to matrix. And so this is this double angle formula here. So it just becomes sine of double the angle. But you can't magically times 2 unless you counter it. And so I countered that by timesing by half, which basically makes them cancel out. So I'm still back to my original question. And so the half is still there in the answer. And so if I said to you, what is the max value of sine 8x cos 8x, then you would just put a box around here and say, what's the max that sine graph ever goes? It's just 1, and so it's just a half times 1. So what's the maximum this graph will ever go to? It's just a half. Just means it's going up and down 16 times. Last little tip for today. If you see derivatives in trig graphs, don't freak out. It's just asking you, derivative is the gradient of the tangent, and so this is also a metric concept, but all that it's doing is it's just asking you to say, in this example, where's the derivative bigger than 0? Where is it going? Up. Where's the graph? Increasing. And so you're looking on your graph, for example here, where is it increasing? There it was going up, there it was going up. So all I'd have to do is write my answer, in that case from 0 to 90, or I saw it went up from 270 to 360. And that's a lovely trick for a question that sometimes makes people panic quite a bit. I hope that you found this video helpful with some of these really cool tricks. If you did, please like this video, subscribe to our channel, and share it with your friends.